Thermal comfort. Why should we care? Well, it's about the occupants of the building, and they like to have a comfortable environment. Okay, but what is thermal comfort? Just one definition of the American Society of HVAC Engineers, the most common definition. Thermal comfort is the condition of mind that expresses satisfaction with the thermal environment. In this video, I will discuss the most common models for thermal comfort. You will learn the key parameters of thermal comfort, and you will know how to quantify the level of thermal comfort. I will discuss the so-called Fanger model as developed in the 70s of the previous century, and I will elaborate on adaptive thermal comfort models. How can we quantify the thermal comfort level? Well, therefore, we use sensation scales. Here you see the most common one as given by ASHRAE. For hot environments, we vote +3, and for cold environments, we vote -3. In Vanger's model, there is also a prediction for the percentage of dissatisfied people based on that sensation scale. For neutral environments, most people are satisfied. That's the good news. But the bad news is that at least 5% is dissatisfied. Is this surprising? No, because we are all unique people who have their own preferences. Based on this sensation scale, the Fanger model also includes a model to predict the mean vote. And I will discuss now the key parameters of this model. The air temperature is in the model, of course, because high air temperatures we don't like. But if some wind is coming in from outside, we like it. At the same time, when this wind has a low air temperature, we don't like it. We experience it as being drought. What we also dislike is too hot and too humid, as well as high levels of solar radiation on our face. But the good news is that we can influence our thermal sensation ourselves by our activity level. Are we running or just sitting, listening to an edX course? We can also change our clothing level. Well, that are all the parameters which are in the model of Fanger. During the last decades, there has been a lot of discussion. One example is personal control. We improve our perception by having influence, by changing the thermostat. There is also a difference between natural ventilated buildings without air conditioning and mechanical ventilated buildings with air conditioning. What also is important is the outdoor climate. We adapt to the outdoor climate. We adapt to our environment. Our internal thermal regulation changes with days and days of high temperatures. So also the temperatures from yesterday matter. This is expressed in the models as being the running mean outdoor temperature. Well, here you see the most important adaptive thermal comfort standards. for the European market and the US market. Here you see one example of the US standard for natural ventilated buildings. For higher outdoor temperatures, we prefer higher indoor temperatures. During winter, with low outdoor temperatures, we prefer lower indoor temperatures with a certain bandwidth. We are used to the low outdoor temperatures, so we prefer lower indoor temperatures compared to the summer situation. There are different standards for natural ventilated and mechanical ventilated buildings. Here you see the natural ventilated buildings, and here you see an example of a mechanical ventilated buildings. In the previous video, I was talking about performance-based design. Well, here you see the design criteria for the thermal comfort in this building, and here you see the real comfort performance expressed by the blue dots. Well, the blue dots fall within the bandwidth of the design performance. So, as a consultant, I'm happy. But the question is, are the occupants also happy? Because they may have different preferences. So, intelligent buildings have to respond to their occupants. That is very important. But then intelligent buildings need suitable hardware for that. And that's the topic of the next video.